explain to the class how you did the bell ringer. And if you would please make sure and like read everything out loud for those that are watching the video.
Okay, I looked back at my notes and I looked at the formula I used for this, which is y minus y1 equals at your slope and your x minus x1. So I plugged in the order pair into the x1 and y1, and then I got y minus 4 equals negative 1 half parentheses x minus 2. So I did negative 1 half x times x, which is negative 1 half x, and then negative 1 half x times 2, and got negative 2. So I added the 4 to the other side and got y equals negative 1 half x plus 2.
Okay, awesome, thank you. Cody, tell us, do you agree or disagree?
I agree,
Okay.
but the way I did it was a little bit different. I didn't really do any work. I just looked at it and like made myself a little graph and
Like you plotted the point and then went down 1 over 2, down 1 over 2, and wrote an equation of that line. Okay. All right, so whenever you distributed the 1 half, negative 1 half times x is negative 1 half x. Can I get everyone to type in your calculator negative 1 half times negative 2? Well, negative times a negative.
I got negative 1.
Did you do negative 1 half times negative 2?
Yeah, I just did how much doing.
Okay, that's a negative 2. So it'd be negative 1 half times negative 2. So would that be a negative or a positive?
Positive.
Positive. So this right here should actually be positive 1. So negative 1 half x plus 1. Hayden, did you have a question?
On the actual equation, what did you say it was?
Oh, you're talking about the original, like the formula? It's y minus y1 equals m times x minus x1.
Oh, no, I thought
Okay, point slope. If they give you the point on the line and a slope of a line, then you use this formula, plug in for x1 and y1 and m, and then you solve it. And now, what's 1 plus 4? 5. So this should actually be negative 1 half x plus 5. Now, the way that Cody was saying he did it, and a couple people did it this way, okay? They graphed it. The only thing here is you gotta make sure your line is straight, and you gotta make sure these are like even intervals. So it's negative 1, or so it's at the point 2, 4, so to the right 2 and up 4. So that would be right there. And then your slope is negative 1 half, so you'd go down 1 to the right 2. And you can also go up 1 to the left 2. And then draw your line. That should get down a little bit more, like that. And now you can write the equation from the line. You already know your slope is negative 1 half. And you look to see where it crosses the y-axis, which is 1, 2, 3, 4, 5. So your y-intercept is 5. So you get y equals negative 1 half x plus 5. Okay? So that's another way that you could do it is by graphing it. Okay? And plotting the point and then using your slope to find your y-intercept. All right, perfect. What questions do you have on the bell ringer? All right, like I said, bell ringers are going to be, your bell ringers are pretty much going to be like your review questions to help you remember stuff from the beginning of the year because you're going to have to know it for the ELC. I'm also going to start including stuff from like solving equations from year 1. We are starting chapter 7. Oh, your vocab. I need your vocab. Chapter 7 vocab. You had that yesterday. Some of you have turned it in already. If you have not turned in your chapter 7 vocab, please get that out. Make sure your name's on it. Pass it to the front row. Pass it to the right. you did it in your student journal, you can just pass up your entire student journal, just make sure your name's on there somewhere. Okay. We are, like I mentioned, we are starting chapter 7 today. Which means we are done with graphing for just a little bit. Okay. After this chapter, we're going to go into chapter 8 or 9, which will be graphing quadratics. But as far as right now, we're just going to be talking about polynomials, and then we're going to be adding and subtracting polynomials, multiplying polynomials, factoring polynomials, and then when we get to our next chapter, then we're going to go back to graphing. But instead of graphing linear equations, we'll be graphing quadratic equations. And if you recall, a quadratic equation is in the shape of a parabola. It looks like a U or an upside down U. Okay, so we're going to learn how to graph those. But first, we need to be able to examine, identify, and classify various types of polynomials. Now, you'll notice as we go through our notes that there are parts that you're going to have to fill in. Make sure you fill those in. And any side notes, you'll want to write that in. Also, I will stop at designated times for you to ask questions. So like while I'm doing the teacher model, you won't be asking questions during that. You'll just be paying attention and copying down. And because of that, I don't want you forgetting any questions you might have. So I've got that section over there that says student questions. If a question comes up, write it down. So that way, whenever I pause and say, hey, you got any questions, you will have that to remind you what questions you have. All right, so what exactly is a polynomial? A polynomial can have constants, which are numbers. It's a number by itself with no variable. Variables, which are letters, and exponents, which are powers. But it can never have a negative exponent, and it can never have a division by a variable. So it can't have like 2 over x. Or it can't have x to the negative 3 power. Those are not polynomials. Also, it cannot have fractions as a exponent. For instance, these right here are what's called no-nos. Okay? So you can't have x to a negative exponent or any type of variable to a negative exponent. You can't have that. X over negative 2, that would be the same as 1 over x squared, and notice I'm dividing by a variable, and that's a no-no. You cannot do either of those things. Something else you can't do is like the square root of x. That is not a polynomial. And that's because you can rewrite the square root of x as x to the 1/2 power, and you cannot have fractions as exponents. So you can't have negative exponents, and you can't have fraction exponents. A negative exponent means you divide by the variable. So you're not allowed to do either of those. And a fraction exponent means you're taking a root. Like x to the 1/3 would be the 3rd root of x. X to the 1/2 means the square root of x. So if you ever see anything like this, it's not considered a polynomial. This right here, this is the formula of a polynomial. A(n) and a(n minus 1 all the way down to a1 and then a0. Those represent coefficients. Those represent the numbers. And then this represents the variables, the xn minus 1, all the way down to x, and then all the way to no x. Okay. So that's like what a polynomial looks like. Each of these are terms, and then a polynomial is where you add the terms together. All right, so you'll see that you have a table, and polynomials have names, and they have two different names. One name is based on the degree of the polynomial, and the other name is based on the number of terms a polynomial has. Okay? So this first polynomial is just the number 47. Okay? Notice it does not have a variable. Okay? So the degree would be 0 because it could have, say, x to the 0, which is just 1, and so that would, like, it cancels out. Okay? So that's how come it's to the 0 power, is because you have 0 variables, and we call this a constant. Anytime you have a number that's by itself and it does not have a variable, it's called a constant. And the degree would be 0 because the highest exponent is 0. Okay? Now, number of terms. This has one term. Polynomials that have one term, we call it a monomial. If you've ever heard the expression mono e mono, that means, one to one. Monomial means one term. Okay. This next one, this right here, this example, 2n minus 9, it has a variable. And it does have an exponent. We just never put that exponent there, and it has an exponent of 1. So the degree is 1 because the n has an exponent of 1. This name is linear. That's what we've been working with pretty much all year, is linear. We've only dealt with like 2x plus 3, or y equals x, or y equals 1/2 x. X has always had an exponent of 1, so it's been linear. Okay? And then this expression has two terms. 2n is a term, and negative 9 is a term. So that's two different terms. We call that a binomial. If you heard the word bicycle, that means because it has two tires. A binomial has two terms. All right, this third example, 5c squared plus 7c minus 3. Your degree is the biggest exponent. So this c has an exponent of 2. This c has an exponent of 1, and this one would have an exponent of 0. So this would be like c to the 0. The degree is the highest exponent. So the degree is 2. When it has a degree of 2, we call that quadratic. You've heard that before in chapter 1. And we already knew in chapter 1 that anything like x squared is going to be quadratic. Okay. Now this one, the number of terms. Okay. All right, so the number of terms, it's the coefficient and the variable. So 5c squared, that's one term. Positive 7c is another term. Negative 3 is the third term. So there's 1, 2, 3 terms. What do we call the device that has 3 wheels? Well, we call it a tricycle, so this one is called a trinomial. So 3 terms is a trinomial. Okay. The next example, 7b to the third power. The highest exponent is 3, so the degree is 3, and the word for that is cubic. If you've heard of a cube. The reason we call it a cube is because it's 3-dimensional. It has length times width times height. That's 3 dimensions. It would be, if it was x, it would be x times x times x, which is x to the third power. That's why it's called cubic. And this only has one term. So from earlier, we know that one term is a monomial. And then this one here, the highest degree we have is 4. So the degree is 4, and that is called quartic, Q-U-A-R-T-I-C. You heard of a quart, 4 quarts in a gallon, 4 quarters in $1. That's quartic. And there's no special name for a 4-term when it has 4 terms, so we just call it a polynomial. So if it has 4 or more terms, just call it a polynomial. Some people have you say like a polynomial with 4 terms or a polynomial with 5 terms. I'm not going to have you do that. You can just call it a polynomial. So the only ones that have special names are a monomial, a binomial, and a trinomial. That's 1, 2, and 3 terms. Also, the terms in this expression are 8 times t to the 4th, negative 7t to the 3rd, positive 4t squared, negative t, and positive 1. Okay? So you want to look at the plus signs and the minus signs like positives and negatives. All right, what questions do you have for me so far? Yes.
Why don't we add up the degrees? You know, like on the bottom it has 4, 3, 2.
Mm-hmm.
Why don't we add them up?
Because in order to combine like terms, they have to be like terms, and like terms have to have the same variable as well as the same exponent. So these two here, like the 7t to the 3rd has an exponent of 3, and this one has an exponent of 2. So that's like you're trying to combine, you're trying to see how many, like if you were to have a cube and then you were to have a sheet of paper, can I like combine those together and call it like a piece of paper? No, I couldn't add those together. But if I had, say, 2 cubes here and 4 cubes here, I can say I have 7 cubes. Or if I had two pieces of paper and 5 pieces of paper, I can say I have 7 pieces of paper. But I can't do a 3-dimensional object added together with a 2-dimensional object. Okay, so that's the same thing here. You can't add a 4-dimensional thing to a 3-dimensional, or you can't add a 3-dimensional to a 2-dimensional. You can't add those together. So we just keep them separate. Okay, let's see if this is going to work. All right, so here's a teacher model. I'm going to work this one out myself, and you will just copy down as I go along and work it out, or write down what I write down and listen to my thought process. Okay, 3z to the 4th power plus 5z to the 3rd power minus 7. So before I do anything, I want to make sure that there's no like terms that I can combine. And all of them have a different number of exponents, or exponents of a different number, so there's no like terms. Okay. So for the degree, you want to look for the biggest exponent. And my biggest exponent is 4. So this is a degree of 4. Okay, so for the degree, I put 4. And then if I look at my table, that's a 4, not a Y. Sorry, my pen's messing up. If I look at my table, a degree of 4 means it's quartic. So that is quartic. Yeah, that's a 4. And then I look to see how many terms it has. 3z to the 4th is one term. Positive 5z to the 3rd is another. And negative 7 is the 3rd one. So there's 3 terms. And looking back at my table, 3 terms would be a trinomial. Remember, tri means 3. Tricycle has 3 wheels. A trinomial has 3 terms. Okay, let me do another one for you. A plus 25. That means 15 times A plus 25. So the degree is the biggest exponent. Well, this 25 has a degree of 0. This 15A has an exponent of 1. That A has an exponent of 1. So my degree is 1. And if I look back at my table, a degree of 1 is linear. So this is a linear polynomial. And for the name, you want to look to see how many terms it has. So 15A is one term, 25 is the second term. So that's 2 terms. So that would be a binomial. Bi means two. Just like bicycle has two wheels, binomial has two terms. Now what questions do you have for me? All right, the next one's directed practice, so I'm going to work this one out, but I'm going to ask you I'm going to ask random people questions along the way. Also, you're going to see that the expression's missing, so you're going to need to write down the expression first before you can work it out. 9 times g to the third power minus 3g plus 5. I'll go answer it so that way y'all can write that down. 9g to the third power minus 3g plus 5. Okay, so the first thing we'll look at is what's the degree? Well, the degree is the biggest exponent. Hunter, what would you say the biggest exponent is? 3. Does the class agree with that?
Yes.
Yeah, perfect. So the degree is 3. Now, what would be the name for that, Brandon, with a degree of 3? Cubic, perfect. So it has a degree of 3, which means it's cubic. And then, Allison, how many terms does it have?
3.
Has 3 terms. Do y'all agree that it has 3 terms? Yeah, 9g to the third minus 3g plus 5. All right, so Rebecca, what type of polynomial is that with 3 terms?
Trinomial.
It's a trinomial. Awesome.
Do we have a worksheet here?
All right, let's try the next one. Morgan, we're going to the second page, the top problem, and you'll need to fill in the expression because I left those blank. All right, here's your next one. 3b to the second power plus 5b minus 5. So that means 3 times b squared plus 5 times b minus 5. All right. Abriana, what is the degree? Do y'all agree? Perfect. And based on it having a degree of 2, Hayden, what would be the name based on the degree? For 2. A degree of 2.
Quadratic.
Y'all agree with quadratic?
Yes.
Yeah, perfect. And like I said, you've actually seen that before in chapter 1 at the beginning of the year. And now, how many terms does it have, Parker? How many terms does it have?
3.
3. So that would be 3b squared, positive 5b, and negative 5. So it has 3 terms. So Parker, what would be the name of that for 3 terms?
Trinomial.
Okay, perfect. Trinomial.
Rather do this than graphing, so.
Yeah, I'm not a graphing person.
Me neither, according to my grades.
All right. What questions do you have for me? Okay. The next one you're going to do with your partner. So before you get with your partner, the first thing you're going to do, actually go ahead and turn your desk and face your partner. You're going to work it out together. Once you get situated, I will pull it up so that way you can work it together.
I can do this, so.
Work with them in front of you. All right, so here's the one you need to do with your partner. 10r to the 5th power minus 7r. 10r to the 5th power minus 7r. So work that out with your partner.
What if we don't know what to put for 5?
Our degree doesn't go up to 5. 5 is quintic. It's QUINTIC. And then after 5, like 6 through anything, you just say like 6th degree, 7th degree, 8th degree. Yeah, you will hardly ever see in this chapter, like we're mostly just going to be dealing with quadratics. Yeah, but 5 is quintic, and they only have special names up to 5, I believe.
Is this like gonna be like what else are we gonna learn in this chapter?
We're going to be doing adding and subtracting polynomials, multiplying polynomials, factoring polynomials.
That sounds really complicated.
All right, Hunter, can you tell me what did you and your partner get for the degree of this polynomial? 5. You got a degree of 5, and then what did you get as the name for the degree?
The thing you said, I don't understand.
Quintic, QUINTIC. Now I said if it has a 6th degree, 7th degree, if it's one of those, just say 6th degree, 7th degree, 8th degree. Anything bigger than 5, just put that. And then what about for the polynomial name, Cheyenne? What did you and your partners get for that? You got polynomial? Y'all agree with that? Yeah. Okay. Now, a polynomial name goes by the number of terms. So 10r to the 5th is one term. Negative 7r is the second term. So there's 2 terms, which makes it a what? It's actually a binomial. It is a polynomial, but it's a binomial.
This one got me because this word quintic thing. I was like, I'm so confused.
Yeah, don't get confused with the degree and the number of terms. Okay, here's your next one. 16n to the 7th power plus 6n to the 4th minus 3n squared.
You said anything after 5 is like 6.
It's like, don't you have to like multiply 16 by like the tiny number?
There has to be put like 7th degree, right?
Yeah, there's no special name for 7th degree. All right. Brandon, what did you and your partner get for the degree?
7th.
And then what about the degree name?
7th degree.
Yeah, you just write 7th degree. There's no special name for 6 and above. And then what about how many terms does it have, Hayden?
3.
It has 3 terms. So what type of polynomial is it?
Trinomial.
It's a trinomial. So 16 times n to the 7th is a term. Positive 6n to the 4th is a term, and negative 3n squared is a term. So it's 3 terms, so that is a trinomial. Okay, all right, go ahead, turn your desk back around. All right, before we move to chunk 2, what questions do you have for me? Let's add a little bit to it. Standard form. Notice you're going to need to fill in the definition for standard form. Standard form. This means they contain no like terms. So this means you've combined all the like terms. So like if you had 6x squared plus 4x squared, you would combine those into 10x squared. And the exponents are in descending order. Descending means largest to smallest. So you go like 5, 4, 3, 2, 1. And if there's anything missing, it just stays out. So like you could go 5, 3, 2, 5, 1, 0, 3, 2, 1. So there's no like terms. All your like terms have been combined, and the exponents are in descending order. Descending means largest to smallest. All right, so an example would be, for instance, x to the third plus 4x squared minus 7x plus 54. Okay, you go by the exponents, and notice it goes 3, 2, 1, 0. Exponents are in order from largest to smallest. Okay. The next term is leading coefficient. Leading coefficient. The term with the highest degree is called the leading term because it is usually written first. Okay, so if it's written in standard form, the term with the highest degree is the leading term. The coefficient of the leading term is called the leading coefficient. So you have a leading term, that's the one with the highest degree, and then the coefficient of that leading term is the leading coefficient. So you got to make sure it's written in standard form first, and then pretty much whatever number is right there in the front is your leading coefficient. Okay. An example would be, for instance, if I had negative 2x to the third plus x squared minus 4. Okay. Negative 2 this is in standard form because the exponent's the biggest, it's there. My leading coefficient would be the negative 2. That's my leading coefficient, negative 2. The coefficient is the number in front of the variable. So like here, the coefficient's negative 2. Here, the coefficient's positive 1. And here, your coefficient is negative 4. Okay. All right, and then the next term is your constant. We've already kind of talked about that already. The constant term of a polynomial is the term of degree 0. It has a degree of 0. That means there's no variable there. It is the term in which the variable does not appear. You only have a number. There's only a number. There's no variable in that term whatsoever. It's just a variable. So a constant has a degree of 0, and there's no variable, or the variable does not appear. Okay, let's do an example. Oh, let me show you an example. So for instance, x squared plus 2x minus 7, this negative 7 would be your constant. Because there's no variable. The variable's not there. It would have x to the 0 power. So that would be your constant, the negative 7. Now let's do an example. 2x to the third power plus x squared minus 5x plus 12. So first, I'm going to look at the degree. The degree is the biggest exponent, which is 3. So my degree is 3. And then the degree name, if I look back at my table, a degree of 3, that's known as cubic. The polynomial name, that's the name or how many terms it has. This has 4 terms and there's no special name for 4 and above. So I would just call this a polynomial. And written in standard form means to make sure that the value or the exponents go down from biggest to smallest. So that goes from 3, 2, 1, 0. It's already in standard form. So I'm just going to rewrite it exactly like it is. 2x to the third plus x squared minus 5x plus 12. It's already in standard form. The leading coefficient is the number directly in front, which is a 2. So my leading coefficient is a 2. And my constant is the number by itself, so positive 12 or just 12. You can write the positive sign if you want to, but you don't have to. We always leave the positive sign off. All right, does this teacher model have 1 or 2 examples?
2.
2. Okay. 2. Let me do another one. (15x minus x to the third plus 3). Okay, so the degree is the biggest exponent, which is a 3. So that would be cubic. It has 1, 2, 3 terms, so it's a trinomial. And then to write it in standard form, you do the biggest exponent first. So my biggest exponent is 3. So this term here goes first, negative x to the third. So I'll put negative x to the third first. And then the next biggest exponent is a 1. So that's positive 15x. So I'll put positive or plus 15x. And then the last one would be plus 3. It has a degree of 0. So it goes from 3 to 1 to 0. So standard form would be negative x to the third plus 15x plus 3. The leading coefficient is this number in the front, so it's negative 1. And my constant is this number in the back that has no variable with it, so positive 3, or just 3. All right, now what questions do you have for me? Okay. All right, we're going to stop right there. We will finish these tomorrow, and then you'll have your assignment over it. You can go ahead and put, like I would just put your notes in your binder. You can put up your calculator.